Hi everyone. Before I start the video for today, I want to make a plug for the resource that I've given you access to, and that's IXL Learning. The site or the link that I've given to you will take you to this particular page, and I just want you to see that it's such a user-friendly, really valuable resource. What this could be useful for is anything that we cover very, very quickly that you know you need more practice in. This is from grade 10 math. So if we scroll down, you're going to see a variety of things pop up that you should recognize. One of them was rational exponents right here, radical expressions. So let's say you're having trouble simplifying the radicals that you find inside a quadratic formula. So here's an example. Let's pop into this and just see what it does for us. What it will do is it gives us some questions and gives us the opportunity to actually try and simplify this. The square root of 50 is the same thing as the square root of 25 times 2. So I could write it as 5 the square root of 2. And then I press it to submit it. And they say, great job, I just found the answer. And I look over on the side. It's timing me. It's giving me a score out of 100, and it's told me that I've answered one question. And it will go on. It's just a really valuable resource, guys. Make use of it if you have the time at all. Also, you've got factoring down here. So some of the ones that are a little trickier might be factoring quadratics with other leading coefficients. Now, if you were to do this one to start off with, you're going to need some time. You're going to need some time to break it down into into the split terms in the middle before you're going to be able to answer your question. That's totally fine. Take as much time as you want. They even offer to help you learn with an example. So to factor this guy. And so you're looking at different things. And here you'll see them breaking it down into the split middle term. And so it gives you lots of chances to be successful with this. So please take advantage of this site. There's lots in here. I think there are even a variety of things. You're going to find quadratic equations in here. You've got, there are a few things we haven't done, but here's one: solve a quadratic equation using the quadratic formula. So again, this is a resource for you. Please make use of it. So what we're going to do now, though, is take a look at the last part of our lesson on word problems with quadratics. So the third type of problem that I wanted to look at was one that is about objects that are moving. And they're moving in relation to each other. There's a right angle. It could be a truck. It could be a car. It could be a person walking. It could be a plane. It could be anything that's in motion. So let me just get rid of this little button here, and I'll have to come back to this. Good. So for example, two planes travel at right angles to each other after leaving an airport at the same time. The same airport at the same time. 1 hour later, they are 390 kilometers apart. If one plane travels 210 kilometers per hour faster than the other, what is the speed of the slower plane? So now we're going to need to draw a diagram of this so we can see it. So I'll move to my solutions here in a moment. And also what they're asking us to find is the speed of the slower plane. That is a clue to help me see, okay, I'm going to let x be the speed of the slower plane. If x is the speed of the slower plane, then the faster plane is going to be x plus 210. I know they're moving at right angles, and at a certain point, they're 390 kilometers apart. So let's go into our solution so we can see what this looks like. Here's x. And moving at right angles to it is x plus 210. And at a point, they're 390 kilometers away from each other. Now, this relationship looks an awful lot like a right angle triangle. And we know from Pythagorean theorem that the hypotenuse squared equals this side squared plus this side squared. And that's exactly what I've written as my beginning equation. And if you look at this, just sort of a glance at it, you'll see that this is definitely a quadratic. It needs some work. It needs some cleaning up and sorting things out and getting it into standard position. Do that carefully. Once you have it in standard position, you could also graph it. And what you're looking for are your x-intercepts. I've chosen in this one to use the quadratic formula. And all I'm showing is the formula itself, where the numbers go, and then I pick up my calculator and do my work, all in one big sweep. So the answers turn out to be 150 and negative 360. Now this is a plane, and it's moving in the air, so we can't have a negative number So our answer is the slower plane is traveling at 150. Of course, you could figure out the faster one, but they don't ask for it. So 210 plus 150, 360. But again, they're not asking us. Okay, let's go back. That is what I've called moving objects. So let me just get this into a spot. So the next one that I've named is called the rate of work questions. Now I understand that you've seen these before. And they are very, very bizarre almost to consider and to kind of figure out where they come from. I did find an explanation and a set of formulas that I think are really useful ones and easy to understand. So let me show you that for now. Let's assume that T stands for the time that someone is working together. So whether it's a thing or whether it's people painting a house or completing a job or whether it's something filling up in one thing and another, let's consider the time that they're going to work together as T. And what we're going to do is take T and divide it by the time of the first thing and the second one, the time of the second one. We're going to add it together and see what happens when it's equal to 1. If this is basically what's happening is we're getting fractions. This person can do this fraction of the job. This person can do this fraction of the job. And so we want to know, okay, this plus this, what makes it add up to 1? Okay, let's go. The cold water tap can fill the tub 1 minute faster than the hot water tap. The two taps together can fill the tub in 4 minutes. How long does it take each tap to fill the tub on its own? Now, we're being asked to find each tap. So I've got a cold water tap and a hot water tap. I could call the cold water tap X if I wanted to. And since it's faster, that means the hot water tap takes longer. So if the cold water is X, the hot water is X plus 1. So let's go and take a look at the example so we can see how we're actually doing it. Here it is. Now, I also came across this table, and if this table helps you understand it because it's the way you learned it years ago, please take use of it. But I'm going to jump in and just do it from here. Let X be the cold tap, and that means that X plus 1 is the hot tap. So the time that they take to fill it together is 4 over X plus 4 over X plus 1. And we want to see what happens when we add this up to 1. Now the algebra to get through this means that I have to multiply everybody by X and X plus 1. When I multiply this one by X, the X's cancel out, and I simply have 4 times X plus 1. With this one, when I multiply by those two, I get the X plus 1's canceling out, and it's still got to be multiplied by X. And then 1, of course, needs to be multiplied by everything as well. So 1 times X plus 1. Okay, once you get this, then you need to go ahead and actually multiply it all out. And you will find that, sure enough, you've got a quadratic popping up. When you get to the spot where you have your quadratic, you could check to see if you could factor it. In this case, it's not going to work. There's nothing that multiplies to be -4 and adds to be -7. So I'm going to use the quadratic formula. Here it is. I plunk in my numbers. I pick up my calculator. Now, I did do a little bit of the work myself because I saw that the numbers were easy, but eventually I had to use my calculator because it was a decimal answer. It gave me 2 answers, one positive, one negative, but negative time does not make sense in terms of a tub filling up with water. And so X is equal to 7.53. And when I interpret that in terms of what X was and what X plus 1 was, the cold tap takes 7.53 minutes and the hot tap takes 8.53. So plus 1. Okay, so we're almost done. We've got one more that we're going to do, one more style, and I've called it the area questions. Area questions you've seen before. It's some situation where you have a relationship between some things and they want you to talk about the area. So what we have here is the length and width of a rectangular sheet of paper. It's 8 by 11. And it says how much must be added equally to the length and the width. So in other words, the same number added to it to double the area. This one is really dependent on a good diagram. So let me go back and see what I have here. So I have a piece of paper 8 by 11 whose area is 88. And I'm going to add a little section on the length of it and a section on the width of it. Both of those are going to be X. So let X be the amount added to each side. So then the area of my new one will be 8 plus X. so along the width, and then the length will be 11 plus x, and it's supposed to equal twice the original, so 2 times 88. That's the hardest part right there. The rest of it, you're going to multiply it all out, simplify it, get it down to a nice quadratic, pick up your quadratic equation. Now, the only thing I would say that's missing from this is the quadratic equation in its formula form. I expect you to do that when you're getting ready to do a question like this, because I want to see that you know it. So the formula, and then we're going to take a look at putting the numbers in, pick up our calculator and get some numbers. We get a positive number and a negative number. Negative does not make sense in terms of adding it to paper's length and width. So my number is 3.85. If I add 3.85 inches to each side, I will double the area. So that in a nutshell then are the strategies and the different types of questions that we have for solving problems using the quadratic model. So your homework comes from a variety of places again. It's partly from 7.7 and 7.8. Please take lots of time to go through this. Give yourself time. Don't worry about it if you're not understanding it the first time. Take a look at my solutions, see if they will help you, and kind of go through it. See if you can identify the places where it didn't make sense so that you can ask about those particular spots in class. Good luck with your work, everybody. Have a great weekend. See you soon.